Hello, my name is Krisma Anak Denis and my matrix number is CD240063. So for our project, we are focused on topic from chapter 2, which is statics of particle, including force vectors, Cartesian vectors, position vectors, the dot product, and equilibrium of a particles. These topics are vital because they help us understand how forces interact in a system and how equilibrium is achieved. This understanding is essential for ensuring that systems are stable and safe under various loading conditions. So, in this project, we will also explore how these principles are applied in real-life engineering scenarios, allowing us to better grasp their importance in designing safe and reliable systems. The objective of this project are centered on mastering key concepts in statics. So first we got force vector analysis that help us understand forces in terms of magnitude and direction, as well as how to resolve them into components along the x, y, and z axis. Next, Cartesian vector representation allows us to express forces in 3D space using unit vectors I, j, and k. Position vectors calculation focuses on analyzing the relative positions of points to calculate moments or torques. Then, the dot product application teach us to use the dot product to find angles, project vectors, and analyze force systems. Finally, equilibrium of a particle emphasize verifying that the net force acting on a particle is zero to ensure stability. Achieving this objective will deepen our understanding of how forces interact in systems and their application in engineering design for stability and safety. Statics of particles forms the foundation of mechanics. It focuses on analyzing forces acting on particles in equilibrium. Particles are often idealized as objects with negligible dimensions compared to the distance involved in the analysis. This simplification allows engineers to concentrate solely on the forces acting on the system without worrying about rotational effects. The principles of statics provide essential tools to solve equilibrium problems where the net force on the particles is zero. These principles are fundamental to many engineering applications, such as designing and analyzing structures, machine, and mechanical systems. Let's discuss the key theories and concepts that form the backbone of this study. So first, we got force vector. A force is a vector quantity defined by its magnitude, direction, and point of application. It is expressed in Cartesian form as F equal to Fxi plus Fyj plus Fzk. So for next, Cartesian vector representations. This simplifies the process of resolving forces into components using unit vectors along a position vector's line of action. Position vector. This describes the relative location of a point with respect to another and is essential for determining force, direction, and calculating moments. For dot product, the dot product allows us to compute angles between vectors, project one vector onto another, and analyze force system or work done. Equilibrium of a particles. Finally, equilibrium is achieved when the vector sum of all forces acting on a particles equals zero, ensuring stability. This equation form the foundation for solving statics problems. Previous studies and application highlight the critical role of statics principles in engineering. For force systems in engineering, research emphasized the importance of precise force resolution in tasks such as robotics, machinery design, and structural analysis using Cartesian vector representations for modeling and simulation. Position vectors have been applied in structural design to simplify internal force and moment calculation in trusses and beams, improving structural optimization. In mechanical systems, the dot product has proven invaluable for determining force projections and angles, particularly in analyzing inclined planes and friction force. Finally, the principle of equilibrium has been used in real-world application to ensure the stability of suspended loads in cranes and compute forces in bridge cables. By implementing equilibrium conditions, we ensure system reliability and safety under varying loads. This study provides a solid foundation for understanding and applying statics concepts in practical scenarios.
Hi, madam. My name is Zachariah Austin Anagruncin, and my numeric metric is CD240166. Today, I will present about problem definition of our case study. So, the objective of the study is to estimating measurement in engineering system, focusing on concept from chapter 2, static of particle. This study highlight the importance of achieving system equilibrium to ensure stability under various loading conditions. The importance of force in equilibrium of force. In static system achieve stability by maintaining equilibrium of force. These forces are resolved into certain vectors, which form the foundation for analyze the validating equilibrium condition. Next is challenge in engineering system. One significant challenge lies is accurately forecasting external forces. This must be decomposed into custom components, and the equilibrium criteria need to be validated rigorously to maintain system ability. The last is consciousness of miscalculation. Structure behavior and design have to driven by precise analytical or numerical calculation. Errors this calculation or incorrect assumption about force or geometry can lead to compromised structure integrity, instability, and anomic design. Next, I will explain about key parameter and variables. Let's begin with force vector. The encompass three main aspects: magnitude, direction, and the point of application. Magnitude qualified force such as a weight or tension. Direction is represented as Cartesian vector, ensuring precise analysis. Finally, the point of application includes the overall equilibrium. The next is certain vector component. Include f, x, fy, and fz. Force acting along the x, y, and z axis. The principle of the equilibrium requires this force to sum to zero. Additionally, unit vector must be overview of 3D unit vector ijk used to resolve force into component. Next is position vector. Position vector describe relative location of orientation between fixtures like support and loads. Geometry spectacle arrangement of structure element including force, flow, and movement. Next is equilibrium of condition. For a system to be a static, equilibrium condition must be met. Fx 0, Fy 0, Fz 0. For static equilibrium, the sum of force must be 0 in all directions. Recent force such as that from support and anchors contain applied load to maintain the balance. Last is loading condition. Finally, loading condition includes static load like a building, wet and permanent installation. Dynamic load predict intermittent loads, example wind, traffic or cleaning activities. Last but not least is distortion versus point load force spread across element of concentrated at specific point. And lastly, I will discuss the challenge in static analysis, which is complete force system, mathematical ratio, force external to the system, and safety margins. So I will begin with complex force system. Static often involves analyzing and resolving multi-force acting in the different direction. Balancing this force is internal equilibrium among diverse force system. Next is mathematical ratio. The mathematical ratio of the dimension and angle determine critical relationship in structure. Misjudging this ratio can lead to calculation error and design flaw. Next is factor external to the system. External factor such as wind or changing load must be considered. This factor can be alter equilibrium condition and require careful integration into the analysis process. And then safety margin ensure to include adequate safety factor and account for unexpected load or condition to prevent failure. In conclusion, addressing this challenge requires of comprising understanding of force system, accurate calculation and robust design principle. By tackling this challenge effectively, we can achieve safe and efficient engineering outcome. That's all from me. Thank you, Doctor.
My name is Aina Najwa binti Morni. My matrix number is CD240149. Today, I will explain about how mathematical modeling and key concepts in statics are applied to solve real-world engineering problems. Our focus will be on two specific problems involving a suspended steel plate and tethered hot air balloon, highlighting the importance of equilibrium and force analysis in system stability. Our first case study involved a steel plate measuring 420 mm by 650 mm with a thickness of 25 mm. This plate is suspended from a point 300 mm above its center. Additionally, the dimension provided indicate that point DE is 195 mm and the materials is steel with a density of 7,920 kilogram meter cube. The problem tasks us with determining the tensions in three supporting cables to ensure equilibrium. To simplify the calculation and focus on essential aspects of the system, we made several assumptions. First, we considered the system to be in static equilibrium. meaning the sum of forces and moment are acting on the system equals zero. The steel plate was assumed to have uniform density and composition, behaving consistently under stress. Additionally, we treated the cables as rigid and inextensible, meaning they do not stretch or sag under tension. Lastly, we ignore the weight of the cables and any environmental factors such as wind or temperature variations, focusing solely on the forces acting on the steel plate. Our second case study examined a hot air balloon positioned 9.144 meters above the ground and tethered by three cables. The upward force exerted by the balloon is 408.23 kilograms, and the cables are anchored to evenly spaced points on a ground plane with grid lines 3.048 meters apart. The challenge here was to calculate the tension in each cable required to keep the balloon stable under static conditions. Again, to simplify the analysis, we assume static equilibrium, meaning the net forces acting on the balloon are balanced and constant. We neglected any environmental factors like wind resistance, which would typically influence a real-world scenario. Additionally, we assumed the cables were straight, messless, and inextensible, maintaining constant tension. The force applied by the balloon was modeled as a single point load at the center of the system, and the ground anchors were considered rigid and immovable. With this assumption in place, we calculated the weight of steel plate using the formula W equals to rho times volume times gravity. After computing, the weight was found to be 530.3 newtons, acting downward as a point load at the plate's center of gravity. To determine the tension forces in the cables, we first identified unit vectors representing the cable's directions and apply equilibrium equations to resolve the force along the x, y, and z axes. The calculated tensions in the cable were TA equals to 129.8 newtons, TB 302.9 newtons, TD equals to 343.4 newtons. Using similar principles to those applied in the first problem, we calculated the cable length and unit vector for force direction. Applying equilibrium equations along the x, y, and z axis, we derive the following cable tensions: A 210.47 kg, B 182.34 kg, C 140.16 kg. These values ensure that the system remains in balance with the balloon stationary and secure in its position.
Assalamualaikum warahmatullahi wabarakatuh. And for my patch discussion, this project demonstrates the practicality of using static to solve real-world engineering problems, using topic including connection of force and vector with Cartesian coordinate, position of vector, dot product, and equilibrium. We grasp how this principle contribute to the balance of the system to accurately function and ensure stability. The first problem involved a suspended steel plate and specifically require that we accurately determine the force acting on the plate and apply equilibrium equations such as the sum of moment must equal zero and the sum of force must equal zero. A second problem, which described a hot air balloon tethered by a cable, was one of the most complex dynamic systems and require calculation to determine the tension force. This illustration demonstrates the value of static in ensuring engineers create systems that are capable of withstanding all kinds of load and condition without compromising safety. Thus, using both theory and practical application, this study demonstrates the crucial role played by static in developing engineering solutions that are stable, efficient, and reliable.
So, in conclusion, it is an essential branch of mechanics of solids which provides a well understanding of interactions of forces and makes stationary systems to balance at rest. Understanding these concepts is critical for engineering designs, allowing them to predict how structures and mechanical systems will behave under various loads conditions to keep them stable, reliable, and safe. In this project, we are going to understand vital concepts like force vectors, Cartesian vectors, position vectors, the dot product, and equilibrium of particles, all of which serve as invaluable tools to solve designs on an engineering scale. As with many things in life, whenever you add a new interaction such as a new element, fixture, or load, the simplest choice may not be the best. So forces must be calculated and passed on to successive elements. From statics of simple mechanical devices to statics of bridges, buildings, and mega projects. Static has extensive application throughout engineering. It expresses the framework for systems to endure stresses, resist external forces, and remain stable. Explore these groundwork principles further to reinforce the knowledge and significance of statics in tackling real-world engineering problems while focusing on creativity and safety. Statics, which is a fundamental of engineering, mixes theory and practice to allow creating systems that are efficient, stable, and reliable, sustainable.